Good evening, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor, Bengaluru, India. This session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. He is passionate about technology and works on Azure, GCP, machine learning, and blockchain. He is also Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you. Thank you, Rashmita. I will just quickly share my screen. Okay, so welcome everyone. Hopefully all of you are safe and you're doing well. And let's go through the agenda. Okay, so now check this out. So basically, today is one of the first session which we are doing, or the one of the first session which I am doing, uh, which will get you started with the Azure Machine Learning using the AML service which we have in Azure. We'll talk about all the different things which are there. Now, apart from that, we have another session which is lined up day after tomorrow, which will take us, you can say, a little more in depth using PyTorch on Azure, and in terms of, you can say, the custom vision domain day after tomorrow as such. And in during the next week also, we have multiple sessions lined up, and where we will further go and we will deploy different type of models. We will deploy different type of architectures. We will check out how can you create uh, different type of solutions for NLP or for custom vision or for any other specific scenarios like that, right? So if you are joining us today, see if you can join the Reactor group and you can be part of the upcoming sessions as well. So everything will line up in a step-by-step manner for you. Okay, so let's get started. Now check this out. So today we'll be going through the Azure Machine Learning Service, and we will understand the what are the various elements of Azure Machine Learning Service. What should we whenever we are deploying any scenario in Azure, what should we be aware of? Like from a point of view of any machine learning engineer or from the point of view of any data scientist, what are the various things we should be aware of over there? And how do you train any model? And one of the major focus which we will have today will be on the visual tools which we have in the Azure Machine Learning Service. And now I'll just walk you through the course module which is also there as part of the uh, meetup page. And if I'll just click on that, so after this
ওটা
session today,
দেখবেন নিচে 92 খানা প্রেজেন্টার আছে
right? Please mute yourself.
হুম
Let me see if I can mute everyone.
হ্যাঁ
Okay, done. Now check this out. So basically, this is the module link which you can also follow after the session today, and we will be covering the all the bits and pieces and all the important things in this module. So after the session, what you can do is you can simply go there. You can sign in into the MS Learn, and you can see that we have there are multiple modules as part of this learning path. So it will help you in understanding the various elements of AML service. So like what is AutoML? How do you configure any AutoML experiment? How do you do early termination in AutoML? Can I enable deep learning over there or not? What are the various algorithms which are supported by AutoML? Can I have explanation of the models as part of AutoML? What are the pros and cons of AutoML? Where does it have an edge? And what else should we be aware of? So all of those type of things will be in the AutoML part. Now, then there are three different, you can say whenever you start with machine learning, generally we have the getting started type of algorithms. So for example, linear regression, uh, logistic regression as such for classification purpose, and k-means clustering. These are the ones which we generally get started with on any toy data set. So this learning module also will get you started. Uh, it will make you familiar with the all the concepts in AML. Plus, how do you deploy any regression model? How do you do any classification? And what is the meaning of regression? Sorry, clustering, and what are the various matrices which are. So this is something which I recommend that after the session you can simply go over there, and there are a few nice videos as well which you can watch on the way. Okay, so let's get started now. Now, the very first thing is, like whenever we work with the machine learning solutions in Azure, there are three different domains which we should be aware of. Like there are three sections in Microsoft Azure AI ecosystem. We call them pre-built AI. So cognitive services are pre-built AI, like these are ready-made endpoints, and any developer will be able to embed their product with these endpoints. And over an API call, you can consume the models trained by Microsoft. So that is pre-built AI, cognitive services as such, right? Amazing solution. Now, then we have conversational AI. Conversational AI is where we have the chatbots. So those chatbots will be those chatbots or the Azure bot services will provide the interface to the channels which we have. Like channels will be like where your customers are. So, for example, maybe my customers are on Facebook, or maybe on they are interacting over uh, my website itself, right? So wherever my customers are, the bot service will provide the channels through which the interaction can be done. And the AI part of the conversational AI will be done either by cognitive services or either by what we are covering today, custom AI. So the third section of Microsoft AI solutions will be the custom AI. So if I just repeat that, we have pre-built AI, conversational AI, and custom AI. So custom AI is the one where you as a data scientist will be uh, training your models. You will maintain your life cycle of the machine learning models. And if something doesn't, you can say the retraining of the models will be done using the Azure Machine Learning Service. And along with, we will do the integration with Azure DevOps, or along with the AML service, we'll do the integration with, uh, you can say GitHub, and we will have maybe GitHub Actions creating the MLOps pipeline. So there is one session which is coming on that as well, like on MLOps, how to create end-to-end MLOps pipeline using Azure. So that will be another long session where in 3 to 4 hours we will understand each and every bits and pieces of MLOps. Okay, so let's get started first. Now I would like to work with Azure solutions. I would like to create some custom AI solution. What is the very first thing? How do I get started with it? Now I will create the AML workspace first. So workspace is the service, or AML workspace is the wrapper where all the components or elements which you require for machine learning will be present. So imagine this box to be that. Now, where is this in my Azure portal? So if I take you to Azure, and if I just take you to my resource group, so I have this one workspace deployed right over here. Now, when you make the workspace, a couple of extra resources also come up. I have one application insights for monitoring. If I want to do any type of you can say monitoring of my models, I would like to understand the any details about how anything needs to be logged when this model is deployed in production. I would like to enable the logging from that particular Docker container into application insights. So the data should be streamed into application insights so we can further analyze what is going on over there. So for those type of scenarios, app insights are available. Sorry. Okay. Now we also have one storage account over here. This one got created default with Azure Machine Learning Workspace. Why is it there? What's the purpose of it? And so on. So we'll just come to that in few minutes. And we have one key vault as well. So if we, for example, if I would like one of my database to connect with Azure Machine Learning Workspace. Then to do that in a secure manner, I will use the key vault, and then we will do the connectivity, or you can say we will keep the secrets over there, and then we will refer the secrets inside the Azure Machine Learning Workspace. So very first thing is Workspace. You click on it, you deploy it, you click on it, and you launch it. Once it launches, this is how it looks like. That's the landing page of Azure Machine Learning service over here. Okay, so now check this out. So we have notebooks, AutoML, Designer, Dataset, Experiment, Pipeline, Models, Endpoint, Compute, Environment, Dataset, Labeling, and Linked Services. So let's get started. Let's see if we can have a look at all of them. And I will also start deploying a couple of things on the way as well. So I'll do the things which take more time to get deployed, right? So I'll go to the compute section first. And in this compute section, I'm going to create the compute instance and the compute cluster. I'll explain what is the meaning of it, but let's just make it first. So you see this is compute instance and it is giving me one default name. In East-US, it is available in CPU and GPU mode. And I'm okay with the configuration. I'll just say create. It will take next maybe 4 to 5 minutes to come up. Okay, now you see this compute cluster. Let's make one cluster as well. Now, when this cluster is created, it doesn't have any instances. Like it will be having 0 instances, and then when we will submit the job, then the cluster will you can say scale out. Then the instances will come up, and then the job will execute there. So we have dedicated and low priority. In case you have any you can say production oriented real time requirement where you would like the model to be trained right now, then go for the dedicated one. If you are okay to run it over a period of time and in the low priority, there is a possibility that maybe the machine may not be available for you after some time. So if that is not the issue, if that is not an issue, then you can definitely go for that as well. Okay, I'll just create with the default configuration. I have this 4 core, 14 GB RAM. I would like this to be called as my cluster. So this is my compute cluster. How many nodes will it have? So the number of nodes actually depends on how many, what's my subscription, what's the quota in my subscription as well. Like I'm using some sort of, like this is a type of demo account where I have limited quota. I definitely can go and increase the quota. So you can do all those things. Okay, let's create this. Now, okay, so let's see what happened now. Okay, apart from this, we have two more things, inference clusters and attached compute. Okay, and you see this, we have data stores here and data sets over there. So let me click on data stores. And this is from where we will start understanding the service itself. So now if I click on the data store and if I just click on this option over here, you will see that I have the capability of directly connecting or registering Azure Blob Storage, File Share, Data Lake Gen 1, which is getting deprecated, and Gen 2, Azure SQL, Postgres, and MySQL database over there directly with my workspace. So if I do that, then what will happen is if there is any data in these locations, then my data scientist or me or you guys will be able to, you can say, don't have to worry about the connection configuration. They don't have to, you can say, get any URL from SQL. They don't have to think about any further key from getting key from SQL, or they don't have to think about any further type of authentication mechanism that has to be configured for uh, from SQL. We can have SQL authentication. We can have service principal based authentication as well. You can prefer the service principal based authentication as over there. Okay, so now, okay, so let me just zoom out for now and let's go back to let's design it first. So now these services where really your data exist, those are you can say will be over here. Like your data might be in ADLS, so that is Azure Data Lake Storage, right? Or your data might be in SQL, or your data might be in some another location as such over here, maybe like storage account. So let me just put few things over there. This is how I'm representing Azure SQL. And this is my storage account like that. So if I register them inside the workspace, that configuration is called as data store. So I'm registering these locations inside my workspace as data stores. Once I do it, I don't have to, the amount of connection configuration that needs to be done later on to retrieve any data from these locations will be, you can say, reduced a lot. Uh, it will be totally abstracted from the data scientist. They don't have to worry about it, like how is the connection coming, going to be established, uh, how is that service principle needs to be, you can say, will the flow of the service principle will happen. They can just focus on the you can say the modeling of the data, or they can work with the data itself, or the ML engineers will be focusing more on the machine learning part as such over here. So the very first element will be the data store, like that. It's only a type of registration. It doesn't fetch any data. It just connects to it. There is no data which is getting loaded or anything like that. There is nothing going to be fetched right now. So data store. Now the second element which is on built on top of the data store, or independently, which is available independently as well, is this data set over here. You see this? Okay, let's close that. Yeah, please. Okay, so data set. Now let me just go to my secondary screen, and I would like to pull one data, one file from your learn module, and I would like to use that right now, just to show you how does it look like. Right, so data store, sorry, data set, create a data set. Now I can create the data set from local file. I can create the data set from data store, which I have registered, like that. We can also do it from web files, or we can also get it from open data set. So I have the link right now with me. I am just going to cancel this and click back there. And let's say from the web file. So this is my link. And this is basically having the toy data set, which is called as penguin data. It's for clustering purpose. Uh, and if you can notice, we have two type of data set, tabular and file. I'll explain that, right? So let's give some description first. Okay. Now, okay, now check this out. So we can change the file format itself from here. Okay, now all of these are metadata settings. Literally by creating the data set, it did not fetched it. Like it's not like getting loaded from any other location. This is just metadata. So it is asking that, okay, what is the file format? Uh, is the first row header or not? Yeah, first row is header. So please, if you can do that. And do I want to skip any rows or not? So let's see if it loads properly. Okay, great. So we are able to have a look at the data. It sort of looks okay for now. Let's go next. And I will just would like to, you can also profile this data set. It will give you the stats about the data set, any the spread of the data set, or any other details as such. If I enable that, it will request me to provide some compute location where the job can execute. So I would like to just create it for now. And what has happened is, see, when you create the second element of Azure Machine Learning Service, will be the data set over there. Now, again, data sets are just metadata. They don't have data as such, and they will just describe how to use the data. Now, I'll give you one analogy over here, or one example as such. Imagine you had multiple tables in this Azure SQL. So by using the data store, I was able to register that Azure SQL to my AML workspace for someone to fetch the data from later on. But from which table should I fetch the data? Should I use the table number one, or the data should be available from should be fetched from data table number two, or should it come from table number three? Where is that information? We couldn't define that inside the data store. Data stores are just like connection configuration. How do you connect? Okay, now, so when you talk about data set, we have two types of them: tabular data set and file data set. So from a diagram, it looks like literally the data will get loaded, but it's not going to happen. It's just like a representation of the metadata. So if I take the same example, uh, the name of the table name, will be something which I can define over here that, okay, I would like to read the table number 1. That's my data set. Or I would like to read in from table number 1, but from 2022, or let's say 2020 onwards. Or I don't want previous data, or I want previous data, like that. Now, apart from this, is the first row header or not? Like, do we have any values over there? Now, secondly, do I have would I like to, what is the file format? Definitely, right? What type of encoding was there? Or apart from that, uh, so this data set, once created, will let me do something like this. I'll just show it to you first and then I'll explain it further. So if I have created that, right? Now just have a look at this. Now the ease of use will be something like this. Like I can click on designer. I can say plus over there. I can say a new uh, model pipeline. I can close all the boxes. I would like to select the compute in few minutes. Oh, sorry, this one. And this is my data set now available, just by like a drag and I was able to drag this on the designer and I can design the solution with it. Now, what else I can do is I can also call this particular data set inside my notebook. The notebook will be the Jupyter notebook where you are writing your entire model uh, script over there. So I can just use this penguin hyphen data over there to get this particular or I can say I can refer to this data set over there. I don't have to define where is this available, in which SQL, or in from which location are we getting this data, or what is this file, in which storage account is this file available. All those things are no longer required to be worried about by the ML engineers or the data scientists who are doing the modeling in that point in time. They can get this data, they can then further start working with the data. So this type of ease of use is what that data set provides. Can I visualize this? So that obviously will be available as well. It will load over here. You can have a look at it to see at least how many rows are there and so on and so forth. We'll come to that in a few minutes. Okay, let's go back. So data sets are the ones which are going to be having the metadata like file name, first row header or not, and any other relevant metadata for this particular data. Now, another very important thing which we would like to understand is what happens if I have multiple files. Let's say in this ADLS, I have 80,000 images over there, or maybe 100,000 images over there. And I would like to load those 100,000 images during my uh, modeling. And I would like to load that recursively over there. So in those type of scenarios, we create the file dataset. Now, what file dataset does is it is more like just it's more like a pointer to the path where the data exists, and then you can recursively read from that. So if I just try to represent it over here, this is file dataset over here. So I'll try to make these small boxes here, maybe representing that files. This is pointing to the files, but it doesn't mean that it is loading the data when I create it. I have to recursively read to it. So what is this going to help me with? I can specify that, okay, inside that ADLS, uh, go to this particular directory, and in that directory, go to this particular directory, and then I'll just point it to that. I'll keep it ready. And then recursively, I can load that later on. So for if you want to load those multiple files as such, we have this option of file dataset. Now, if I want to load my data in a pandas data frame, then I create a tabular dataset. So we have these two variations available. Now, once we have done that, you saw how easily can we drag and drop and work with it and so on and so forth. So now what happens if I do not want to do that? I would like to use notebooks to do this, right? So if I just take you back to my uh, Azure Machine Learning Workspace, you see this, the compute which we created a few minutes back, now they're running. Let's see, yeah, so you see this succeeded. It has 0 nodes. We haven't executed anything there. So it's having 0 node. This is running properly over here. So I hope you can see that it is having Jupyter Lab, Jupyter, VS Code connectivity, RStudio, and Terminal available. So what is the meaning of that? Let's click on one of them. So basically, I understand. Okay, please open. It may ask me to authenticate my account over here. I'm also opening this in incognito mode. So that may also ask it to authenticate or not. So I can click on this user. This is my user. I can create my Jupyter notebooks over here. So like that. So what is compute instance? Like this normal Jupyter notebook, which is running in the cloud. So if I define what is compute instance are the development environments which you will be using to develop the various pipelines or models which you are thinking about right now, right? So this is a development environment. And where is this development environment existing? It's in the cloud itself. And it is already pre-installed with the most popular uh, editors or you can say the various editors which are available. Now, what happens if I do not want to use it, right? So can I use my maybe my workstation right now, maybe my laptop right now? Yeah, you can totally do that. You just need to install Azure Machine Learning SDK locally in the laptop and don't use the compute instance. You can directly submit the job against the AML service. All that is totally possible, right? So more on that in the day after tomorrow session, where we will be writing the PySpark based CNN model as such. Okay, now notice this. So this is the compute instance. And okay, so this is where we will be, this is our development environment, and we will be developing things from that. And it comes pre-installed with a lot of libraries. And if you would like to install something else, you totally can do that. Now, when we submit the job, right? Let's say you have created the particular, uh, you want to train the model. Now, when you submit the job, so for the purpose of submitting the job, we have this option which is called as compute cluster, which it was the other one which I created few minutes back. I didn't had so many nodes, but you definitely can have nodes based on the quotas of your subscription. So what is this compute cluster? This is the one where the model training will happen. So over here. Now I may be submitting my job from here, right? Data set might be getting referred from there, right? Like that. And you also saw that when we create the data set, it is possible to create the data set directly from the web link as well. Or you can also create these data set from your local files. So it's not that always the data sets will be created on top of data store. So actually, I also use the web URL to create the data store. So compute cluster are the training cluster where the training will happen once we submit it. Now, so today what we are focusing on is that what are the tools by which I can visualize, or what are the visual tools which are available by which we can train the models. Now, I think first, the very first time when I saw the visual tools of Azure was somewhere in around 2012 or 13 as such, or maybe 13 or 2014 as such. And we used to have the old Azure Machine Learning Studio. There was another one, like before what you are seeing right now. There was another one which we used to work with. Now, and I may be exaggerating slightly, but I don't think if in that point in time, in 2013 or in that point in time, I don't remember any other tool which was so evolved. There were amazing libraries available, but that visualization tool which was there was pretty good, right? And what you see today is another evolution which has happened on top of it. That had few limitations of like you cannot create your own compute cluster. It used to run on the default settings. So if I want to train something in a distributed environment, then I didn't had any option to do it. All those things have been resolved now, right? So the designer which we are going to focus on today is what I was is something which is here. So what you can do is you can literally create your solutions in this designer by dragging and dropping. That's the way it is, right? And If you know what you are doing, the amount of time it takes to design the solution in Designer will be very less. You will be able to create uh, pretty extensive solutions over there. Does it support deep learning? Yeah, it supports that, right? So a lot of support is there. Uh, is it having all the features? Maybe we can check it out. Now let's go back and have a look at this first. So if I just take you back, and today is not the Jupyter Notebooks day, so let's close it. And let's click on Designer back again. So my previous experiment already is open right now. So I would like to select the compute cluster where I would like to train this once I create that. So uh, that that's the one. Okay. So this is my data set. Now we have these modules here, like everything is modular. You can drag and drop and you can work with that. So you will see that on the left hand side, this is where we have some sample data. We have few of the like data input and output like modules which can do data input and output, like enter the data manually or feature selection, filter based feature selection. uh, Multiple algorithms are there available. I can also write my own Python model over there. I can run my own script as such whenever we need. And we also can execute our scripts in the designer. We can work with the text analytics and a lot of like extract the n-gram from the text. A lot of these type of things are there since many years uh, over there. And now I have this link for you. I kept it open with me over here. Now, those of you who are new to the machine learning itself, what you would like to do is maybe if you can open this link in Microsoft documentation, you will find that they have created this workflow or this cheat sheet over here where we will be able to understand based on what we are doing, which type of algorithm can be selected and what are the various parameters or what is the behavior of that algorithm if the data size is very big or if there is a particular type of you can say uh, distribution which is there. So what is the behavior of that particular algorithm? Now if I just have a look at this, right, and this is not an exhaustive list over here, but it's having you can say a lot of them in the same screen. So this is from where you should start, like what do you want to do now. And if you can see that in this star formation we have like extract information from the text. I want to predict between several categories as such. I want to predict between two categories. I would want to generate the recommendations over here. Would like to predict the value, discover the structures, find any anomalies as such, classify images over there. So this is, let's say you are sitting over here and you are thinking it through. Okay, what should we do today? So maybe we can predict between two classes, right? So we have two class classification algorithms. And then if we zoom in, we can see that we have multiple options here. That if we have two class support vector machine as such, then under 100 features, like is it optimized to do what? Like what is the behavior of this algorithm? Like fast training, linear model, fast training, accurate, uh, and deep learning framework, for example, fast training time over here in anomaly detection as such, PCA based anomaly detection. Now, if you want to predict any values, now I would like to just you can say get started from somewhere. So let's say you want to predict any numerical value. You want to predict the output, which is a sort of numerical value. So we have regression analysis. So we have families of we have different regression algorithms which you can go. These algorithms will be available in drag and drop manner, right? What happens if I would like to let's say what happens if I want to import something which is not there, right? Which is not possible here or whatever, right? Whatever reason you would like to get another let's say library which is pretty popular, then there are two options which are possible. First is literally you can write your own custom scripts as well in designer, but I will recommend that if when we create custom solutions, it's better that we use the Jupyter notebook, and then there is no limitation. It's totally whatever, whichever library you want to use, whichever framework you want to get, in whichever way you would like to train your model in distributed manner. You want to have parallelization between the data. You want to have parallelization of the model itself. Whatever you would like to do, you will be able to perform that. So that is where we can say we would like to go towards the code based approach. So if I would like to differentiate between designer and the compute instance based any or any programming language based modeling will be like uh, let's say if we are sort of getting started, design is amazing. You will be able to absorb machine learning, and once you become very comfortable with it, you would like to create something which is so complicated, which may take you more efforts here to find the workarounds. You can just write that particular snippet over there in Python using uh, the notebooks. Okay, now let's go back and let's see if we have some other things to be seen over there. Now, I would like to, let's say we want to classify between two categories. So we have two class classification, multiple categories, multi-class classification, extract information, text analytics to be done. Now, this is the sheet. I'll just put this in the chat for all of you to bookmark, and you can also find it yourself if you just use your favorite search browser. Okay, now, so I'll take you back to my machine learning designer here. Now, let's say I would like to complete this particular flow. So how will any typical flow look like when we are doing the modeling as such? Uh, I can see there are a few questions in the chat. I'll take your questions in few minutes. So right, just hang in. Okay, now so we would like to create the first we would like to use k-means clustering over here. Now what I can do is I can literally, let's say I can select my columns from here. I can simply say select uh, columns in the data set. So I would like to select the specific columns. So I can use something like this. And then I have to give the value there. I'll give it in just few minutes. And if we have clean, let's say if we have missing data,
Your screen is not shared. I don't know. Oh, sorry, sorry.
is it
Sorry.
not? Okay, so uh, okay, so let's say in case you have missing data, then we have these modules where we can do the cleaning of the missing data. We have the options to go for custom substitution, replace with mean, mode, median, or remove the rows if you have less amount of missing data, or maybe would like to remove the columns also if there is a lot of data which is missing over there. Now, what is this red icon which is coming here? This will represent, or this is trying to say that you have something which needs to be added over there, like something, one more step needs to be selected. I'll show you something and we will quickly finish this. And let's say I would like to normalize my data. I would like that the data which I am going to work with, it should not be scaled or it should not be out of proportion on some particular scale. So I have the options to go for various type of normalization mechanisms. Z-score is something which is very popular, which you may have heard about before. Min, max, uh, 10H, and so on and so forth. Now, what happens if you would like to do something which is not there? Use the Python script option, drop it, and then you put details inside it. Now, I would like to split my data. So let's say this is the split module. Let's drop it first. So now I would like to have the split which is maybe randomized, which is a stratified split, or what is the split percentage? I would like to have, let's say 70% split, 70-30. I would like to create maybe three splits. If I would like to create three splits, I have to drop the split data two times. Then I will create two and then further one more split out of it. So you will have your three splits created on top of it. Now, should I do randomized or stratified or not, right? All those things are possible. So if you want to create stratas, it's just available in the module itself. Now, how will we will be looking for the you can say how we will be doing the model or training will be, we have this trained model module like that, and it is looking for data and it is looking for algorithm also. So I have to look for the algorithm as well. So I can see I have few of the clustering algorithms over here visible, and I will go for the first one, k-means clustering, and I will just gonna want to add it something like that, like this. Now it became it's not looking pretty you can say uh, structured right now. So let's see what can we do to make it more structured. So we have these options over here which are going to make it slightly more aligned. Let me say auto layout. Yeah, okay, looks better now. Now I have the okay, sorry. Okay, let me just remove this. And we are doing clustering. So we have like for clustering, we have specific modules. And the one which I dropped was more for more generic, non-clustering type of scenarios. So I'll drop the one which is train clustering model. So let's put it like that. Because here we are concerned about that once the clusters are created in k-means, then the which value get assigned to which value to which cluster, and then the iterations will go on top of it. So this is where we are doing all of those type of things. And let me just drop the last one, which is going to be the assigned data. Okay, so data to the cluster. Okay, something like this, like that. Now okay, so what I have done is it takes around it takes around more than 5 minutes for this to train. So I have the exact thing created over here. I just over here, and that's the same thing. I just wanted to show you how easily can you create your models as such. Now let's have a look at this, right? So we have selected few of the columns here. Literally, you can click on this edit option, and you will be able to see these columns. You can add by value, add by name, and you can work with that. And once you let's go and have a preview of the data first. So let's maximize it. Okay, so I can see I have it's a toy data set. So basically, we have these 5 columns, 50 rows are visible right now out of 344, and I would like to see that if you have any further information for me. So there are 2 missing values here. I clicked on it. Okay, so we have some missing count here as well, and few values are missing over there. So once you are able to visualize the type of your data, min max values, count, standard deviation over there, skewness is there or not, and the and that statistics or the profile of your data, you can further drop the or use the modules accordingly. So here we have selected the columns where the values are missing. So it was missing in all of them, nearly all of them. So I have used the all columns over here. And then what type of treatment should be done of that missing uh, missing now. So right now we are dropping these values. So a lot of rows are not missing. So I don't have to worry about losing information. Only two, the count was showing only 2 over there. Now normalization is basically we are doing min-max normalization, and obviously it can be done on the numerical column. So you have to make sure that you have the correct column selected, otherwise you will get some error. I'll show you how you will be able to find the errors also in another designer over there. So what type of splitting do I need to do? Okay, I didn't notice that it was on 50, but let's say it should have been on at least 70-30 or maybe 80-20 over there. And once you get more advanced, like you can think of maybe 3 splits. You can go for, even if you want to find the consistency of your models, if you would like to find the you can say the behavior of your model once it sees new data, go for cross validation also, right? Please mute yourself, right? We can hear there is some background noise right now. Okay, yeah, Devdutta, you can ask your question. I can see the hand is raised. Yeah, please go ahead. Or use the chat window. Okay, so now, okay, so
Over here.
yeah, you want to ask the question?
No, fine. I have got my answer.
Okay, okay, okay. So okay, so this is the algorithm over here. Now we have, as you guys are aware of that, how many centroids should be there in this cluster. Uh, from where can we set the hyperparameters? So if I click on any of the modules, you will notice that on the right hand side, those properties which you set using scikit-learn or any property which you set in any other programming language will be available somewhere in a you can say in a pop-up in a drop-down menu on one of the side as such, like you can see here. Now from here we can do those. Okay, now this is where the assignment to the clusters are happening. I just want to show you a couple of more things and would like to take you back to the designer. Yeah, please do that. Okay, now I have a couple of more models which I trained for you to have a look at. So here is an example of regression going on, the simplest possible regression, linear regression. So if you're new to ML, you can start from here. This is your starting point, then slowly make your way using the learning module in the chat. So you can see that we have slight differences between two. I'll mute everyone. Okay. So now we have slight differences in the modules, but not too much of difference in the overall structure of it. What happens if I would like to see any score, or I would like to have the evaluation done on top of it? So I want to see the matrices. So I didn't drop it, but we have evaluate model. So this needs to be connected somewhere like that. And here my matrices will come for regression. Now, and what happens if I would like to compare two algorithms at the same point in time? Do we have the capability of doing that? You will be amazed to see how structured will that be looking if I click on one of them. So let's see. Okay, so here we are doing multi-class classification for character letter recognition as such. So the importing data, splitting data, uh, we are comparing two different algorithms at the same point in time. And once we are training these two, this is where you will see the evaluation, this versus that. Like which one is, we can say, let's see if we can see the results. So we will be able to visualize that, okay, what was the output of one versus the other one. So these type of things. Now, let's say here two options are there and I have three algorithms. Then how do I do it? I have to drop more modules, or rather maybe a Python script to take care of that. So those type of things you will get, you will understand once you start using the service. If I click on this DenseNet, I am not sure if it is trained or not. I do clicked it, but it took a lot of time, so I was not sure. Seems to be trained. So this is one DenseNet where we are using basically PyTorch model inside the designer over here. And the evaluation is going to happen like that. And if I just show you how the errors will be looking like. So I have one which I have kept uh, for for us to have a look at, which I think I didn't resolve, should be in this one, something like that. So I will be able to understand that, okay, something went wrong over there. What went wrong? We can have a look at from the exception over here. Like what is the reason why it is throwing that error? And the issue is right now is something to do with the selecting of the column which was not supported in few of the steps before. So you will be able to find your uh, results from here. Now, uh, I would like to take you back to the one which we were just creating and just want to show you something. So this got trained, and I would like to deploy this. So we have this inference pipeline. I would like to create that. So let me see if I can submit this. Okay, so it will run one more time. Okay, please do that. Okay, so it will take few minutes for it to just flow one more time, and that one more once that flow happens, it will find that whether I have done some wrong configuration somewhere or not, and so on and so forth. Now what it does is, after my model has been trained, what do I do? Like where is the rest of the model? Where is the rest of the model management? Where are the features by which I can save my model, version my data sets, and so on and so forth? So once this training has been done, we have the model registry already available inside the service itself. So if I just take you back, you see on the left hand side we have these models over here. Now once you train something, you register it over there. I think this is the old workspace. Let me see where did the other one went, where we were just seeing the things getting trained. So there should be one more over here. Okay, so over here. So we can register after training the models here. Like you can have the pickle files saved over here, or you can have the ONX models also kept over here in this registry. And then it will be having versions there, like version, latest version, and so on and so forth. And you can put tags and descriptions in accordance to the hyperparameters which you have used maybe 1 month back uh, when you did train that model in the description section over there. So even in a later point in time, you will be able to understand the scenarios or whatever algorithms you have already evaluated to reach that or to make that trained model. So all of that is available in this module. Now you see this endpoint. Now if I deploy something, maybe like in real time endpoint, or if I deploy something as a batch endpoint, so or as a batch endpoint basically. So here I will see the URLs of that. Like, okay, how can the which particular URL or endpoint can I give to my developer, and how can they use the key with a sample code to be able to do an API call to the model and do the inferencing with it. So all that information will be available here. So let's see what happened with the designer, which we clicked on. Did that continued or not? So, okay, this is the one which we had kept for the troubleshooting purpose. The one which we were looking at was this one, I think, and or not. Okay, so let me just identify. Okay, so I'll keep the tab open this time. Not sure which one did I click on. Okay, now basically, okay, let's do one thing. I think let's see if it let me go ahead with it, and let's create one new endpoint. Regression endpoint is fine, and let's see what happens. Okay, so now what is going to happen if once we are able to publish this and so on and so forth. If I take you back to the compute section, right, you see this inference clusters which we have, and if I click on this new option over here, you will notice that we have the capability of deploying into Kubernetes from Azure Machine Learning Service as such. What happens if I do not want to deploy in Kubernetes? I would like to deploy in Azure container instances. Can I do that? That all those configurations are technically possible. And as soon as you have registered your model, or you have this model which is here, maybe M1 model and M2 model, and so on and so forth, you can simply using Azure Machine Learning SDK, you can fetch this model into another location and you can just run it using some maybe uh, put that inside one Docker container and run it in any platform which you would like to use. So inference clusters basically are is Kubernetes, and one Azure Kubernetes cluster will be there where we can do the AML model deployment. Okay, so if I want to deploy in Kubernetes, basically I'm also thinking about where is that image which needs to be created, or where is that image which will be saved as well. So what they have done, they have provided the entire stack of tools needed for somebody. Now, what with simply like you can say, we have the capability of creating ASR or Azure Container Registry, sorry, ACR over here. And if I just go one step back over here, and if I just click on create and deploy one. So let's say Azure, or let's say just container registry over here. So this is the repository for images. Now, the next thing which I have to do is basically specify all the dependencies. So we have mechanism where we can specify the environment file, and using that environment file, the Docker image will be created, and this image will be kept inside ACR once I have finished my configuration. Along with that, if you really have to deploy the model in production, there is another component called as a we can say we have a script file over there. So what this core file does, or this core script does, score.py, is that it is having two functions. It will initialize the model when it is running in production. It will also uh, load the data which is coming over the API call, and will do the model.predict and will respond back. So those informations needs also be written. So once I have this, I can just simply do my further deployments. So Azure Machine Learning Service will provide uh, all these components, and many of them which I thought of covering, but we will be seeing in the upcoming sessions day after tomorrow and during the next week. And we can also integrate the the entire life cycle to with the DevOps tools which we have to create the end-to-end MLOps pipeline, and try to uh, you can say integrate the best practices, or try to automate the flows, try to do the testing of the code submitted by my uh, data scientist in that point in time, and so on and so forth. Okay, couple of more interesting things which we can have a look at is that once you deploy the model, that's not the end of we can say that's not the end itself. What we also would like to see is that if we can have the data drift monitor created. So if I have deployed the model in production, and suddenly, or because of any seasonal pattern change, or because of some XYZ reason, the incoming data has a different pattern or different spread, or is having a different distribution than what I trained the model with, then this data drift monitor will find the difference in percentage term and will notify me that okay, the model's performance is degrading. Please go and do something with it. So I can go and further start think about my uh, retraining cycle. Or secondly, let's say I trained the model on the data in the from which I got from SQL, and that data was of you can say was few month old data, and then there was uh, another, so maybe another system has ingested or has dumped more data inside SQL, and my data model was trained on an older version of the data set, or on the files, or on the observations, or the rows which were older, and now new patterns or new data has arrived. So how will I come to know? If I have this data drift monitor in place, it will be able to send the notification to, basically I will be able to understand from the alerts that everything is going red. Go and start thinking about the retraining. So this is what I had for the session. We had 1 hour with us, and we will continue with this flow day after tomorrow, where we will use the compute instance to create the first model with PyTorch, and we'll go in the custom vision field with Azure services. We'll see if we can containerize the models and if we can deploy them as well in one session, or over a period of time. We'll cover all of that. I'll just go through the questions, and okay. So there's one question which I can see. Can we create AML dataset that is pointing to an external data source, say Google Drive, with images? To Google Drive with images as such. So I think you saw that, right? I also used literally the file which is hosted on GitHub. Get that URL of that Google Drive, and you can. I also didn't had it locally in any of the data stores or so and so forth. So I think you got your answer. Okay, so if there is any follow-up question, or if there is any more question which uh, you would guys would like to ask, then feel free to do that. And how can we further go through the modules will be by using MS Learn over here.
Just one thing. So all the codes that are written within these algorithms, those are written in Python in Azure modules.
inside the designer.
Inside the designer means you are using all the models, right? Means maybe the to train the data and like that. So all are written in Python code.
No, there is these modules are ready-made modules. These are, you can
Okay.
say, provided by Microsoft, and as per my understanding, uh, there is no documentation on what they are using at the backend, or maybe I never found that documentation, but uh, pretty interesting to know how they are doing. Maybe C++. We can find it.
Okay, so we cannot see it over here. Like there
No,
lies no customization to do over here.
no,
Okay.
right? For that, I can use the Python version. So I really have to drop this, and then I can write my
Yeah, now I understood. Like here we can add the code. Hmm, okay.
yeah. Okay, so I'll just paste that the learn module link in the chat window, and I'll also put my LinkedIn profile. So if you have any follow-up question, find me on LinkedIn and feel free to ask them.
Is there any document means is there any OneDrive or such kind of link means where we can get some document regarding this?
Uh, Check out the link which I have just kept in the which I have pasted in the chat. That will be having the proper documentation of all the things which we have covered. Look at that. Okay, so any other question? Anyone? Any other thing which comes to mind? Join us for the session day after tomorrow, and please join the Reactor group as well for the upcoming sessions. We have a lot of sessions which are lined up on AI and ML itself, and we also have few very interesting sessions where we will be analyzing the rocks which are which the NASA's mission to moon got, and how is that data processed or analyzed, or what did NASA do with it, and so on and so forth. So there are amazing sessions which are more scenario based also, and there are few sessions which will make your which will build up the foundation. So please find the links and join us for the upcoming session. Thanks everyone. Have a very nice day.
Thank you, Shivam, for the session, and thank you all for joining us today. Please do your feedback about today's session, and please feel free to use the Learn module link, which is shared in the chat section. This will give you access to additional resources to take your learning further. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you all once again, and enjoy the rest of your day.